Good day everyone. For today's video, I'm going to show you our chapter 10 in our CCNA version 7, the Bridging SRWE course. Let's begin. For our chapter 10, we have our land security concepts. We have here our 10.1 to 10.1.5 endpoint security, network attacks today, network security devices, endpoint protection, Cisco email security appliance, Cisco web security appliance, and our understanding to endpoint security. Endpoint security, network attacks today. We have here the distributed denial of service, or our DDoS, data breach, and malware. Example of malware is a ransomware. And we have here the diagram. This is a figure of example of our ransomware. We have here the question, so that you can recover your files. And in our network security devices, we have 3 network security device, which are our VPN, NGFW, or a NAC. Our VPN enabled router is a virtual private network. This is our VPN, and our NGFW, the new generation firewall. This is our NGFW, and for our network access control is this one. Endpoint protection. The figure is a simple topology representing all the network security devices and endpoint solution discussed in this module. We have your internet, remote user with VPN client, our VPN enabled router, our new generation firewall, NAC, our ESA and WSA, and we have here our wired and wireless endpoints secured with AMP. Example of the endpoints are our laptops, desktops, servers, and IP phones. Our ESA is our email security appliance, and this WSA is our web security appliance. Cisco email security. In this figure, the Cisco ESA discard the email with bad links. So the threat actor, this one, sends a phishing attack to an important host on the network. So the firewall forwards all the email to the our email security, and our email security analyzes the email, logs it, and if it is malware, and if it is malware, it discards it. So our Cisco web security appliance, the user attempts to connect to a website. The firewall forwards the website request to the web security. The web security evaluates the URL and determines it is known blacklisted site. Our web security discards the packet and send an access denied messages to the user. So that's our for our endpoint security. And to our access control, we have here the authentication with a local password. We have here our R1 config hashtag line VTY04 and line password config line password is Cisco, then login. It requires a user and a password, both of which are encrypted during transmission. The username and password can be authenticated by the local database method. It provides more accountability because the username is recorded when a user logs in. The following example illustrates SSH and local database methods of remote access. User accounts must be configured locally in each device. In a large enterprise environment with multiple routers and switches to manage, it can take time to implement and change local databases on each device. The local database configuration provides no fallback authentication method. For example, what if the administrator forgets the username and password for that device? With no backup method available for authentication, password recovery becomes the only option. Our AAA components. Our AAA is our authentication, authorization, and accounting. It is similar to using a credit card as shown in the figure, this figure. The credit card identifies who can use it, how much that user can spend, and keeps an account of what items or services the user purchased. Our authentication is the who you are question, your name, and our authorization, how much can you spend, the credit limit, and for accounting, what did you spend it on. So this is our accounting. We have your amount, activity since last statement, posted, sold, and reference number for our accounting. Authentication. Local and server-based are two common methods of implementing AAA authentication. For this, users authenticate against the local database as shown in figure. Local AAA is ideal for small networks. The client establishes a connection with the router. The AAA router prompts the user for a username and password, and the router authenticates the user and password using a local database, and the user it provided access to the network based on information in the local database. In this figure, the client establishes a connection with a router. The AAA router prompts the user for a username and password. The router authenticates the username and password using a AAA server. This is our AAA server, our AAA router, and this is our remote client. The user is provided access to the network based on information in the remote AAA server. Authorization. This is our remote client. When the user has been authenticated, a session is established between a router and our AAA server. The router requests authorization from the AAA server for the client's requested service, and our AAA server returns a pass or fail response for authorization. Accounting. The remote client When the user has been authenticated, the AAA accounting process generates a start message to begin the accounting process. When the user finishes a stop message is recorded and the accounting process ends. Client or our supplicant. This is a device running 802.1x compliant client software which is available for wired or wireless devices. Switch authenticator. The switch acts as an intermediary between the client and the authentication server. It requires identifying information from the client, verifies that information with the authentication server. Our authentication server validates the identifier of the client and notices the switch or wireless access point that the client is or is not authorized to access the LAN and switch services. For our 10.3, we have here our Layer 2 vulnerabilities. We have here our Ethernet frames, compromise, initial compromise. We have application, presentation, session, transport, network, data link, and our physical. Our application, presentation, and session are the HTTP, HTTPS, POP3, IMAP, SSL, and SSH. Our protocols ports are transport, and our IP addresses is network, and Ethernet frames is our data link, physical is our physical links. MAC table attacks includes MAC address flooding attacks. VLAN attacks includes VLAN hopping and VLAN double tagging attacks. It also includes attacks between devices on a common VLAN. DHCP attacks includes DHCP starvation and DHCP spoofing attacks. ARP attacks includes ARP spoofing and ARP poisoning attacks. Address spoofing attacks includes MAC address and IP address spoofing attacks. For our STP attacks includes spanning tree protocol manipulation attacks. Switch attack mitigation techniques. Port security prevents many types of attacks including MAC address flooding attacks and our DHCP starvation attacks. DHCP snooping presents DHCP starvation and DHCP spoofing attacks. Dynamic ARP or ARP inspection prevents ARP spoofing and ARP poisoning attacks. IP source guard prevents MAC and IP address spoofing attacks. For our MAC address table attack, we have the switch operation review. In this topic, the focus is still on switches, specifically their MAC addresses table and how these tables are vulnerable to attacks. Recall that to make forwarding decisions, a layer 2 LAN switch builds a table based on the source MAC addresses in received frames. Shown in the figure, this is called a MAC address table. MAC address tables are stored in memory and are used to more efficiently forward frames. So for you to see our MAC address, you have to type show MAC address table dynamic, then the VLAN MAC address type ports is appear. MAC address table flooding. The threat actor, this one, is connected to VLAN 10 and uses MAC OF to rapidly generate many random source and destination MAC and IP address. Over a short period of time, the switch MAC table fills up. When the MAC table is full, the switch begins to flood all frames that it receives. As long as MAC OF continues to run, the MAC table remains full and the switch continues to flood all incoming frames out every port associated with VLAN 10. The threat actor then uses packet sniffing software to capture frames from any and all devices connected to VLAN 10. MAC address table attack mitigation. Another reason why these attack tools are dangerous is because they not only affect the local switch, they can also affect other connected layer 2 switches. When the MAC address table of a switch is full, it starts flooding out all ports including those connected to another layer 2. To mitigate MAC address table overflow attacks, network administrator must implement port security. Port security will only allow a specified number of source MAC addresses to be learned on the port. Port security is further discussed in another module. So this is our MAC OF. Next is lastly for our LAN security concepts is our LAN attacks. VLAN hopping attacks. A VLAN hopping attack enables traffic from the VLAN to be seen by another VLAN without the aid of a router. In a basic VLAN hopping attack, the threat actor configures a host to act like a switch to take advantage of the automatic trunking port feature enabled by default on most switch ports. So, this is our attacker, our switches in server 1, server 2. VLAN 10 to server 1, VLAN 20 to server 2, our switch 802.1Q trunk to our switch, and our attacker to the 802.1Q authorized trunk. VLAN double tagging attack. Step 1. The threat actor sends a double tag 802.1Q frame to the switch. The router header has the VLAN tag of the threat actor, which is the same as the native VLAN of the trunk port for the purposes of this example. Assume that this VLAN 10, the inner tag is the victim VLAN in this example VLAN 20. Step 2. The frame arrives on the first switch, which looks at the first of 4 byte 802.1Q tag. The switch sees that the frame is destined for VLAN 10, which is the native VLAN. The switch forwards the packet out all VLAN 10 ports after stripping the VLAN 10 tag. The frame is not retagged because it is part of the native VLAN. At this point, the VLAN 20 tag is still intact and has not been inspected by the first switch. switch. Or step 3, the frame arrives at the second switch which has no knowledge that it was supposed to be for VLAN 10. Native VLAN traffic is not tagged by the sending switch as specified in the 802.1q specification. The second switch looks only at the inner 802.1q tag that the threat actor inserted and sees that the frame is destined for VLAN 20, the target VLAN. The second switch sends the frame onto the target or floods it, depending on whether there is an existing MAC addresses table entry for the target. Our DHCP messages. We have the server, the client. The client send the message to the server. Then the DHCP offer unique the unicast will send it to the client, and the client broadcast it to the server and unicast again to the client. DHCP attacks. DHCP starvation attack. The goal of the DHCP starvation attack is to create a DOS for connecting clients. DHCP starvation attacks require an attack tool such as Gobbler. DHCP spoofing attack. It is occur when a rogue DHCP server is connected to the network and provides false IP configuration parameters to legitimate clients. Wrong default gateway. The rogue server provides an invalid gateway or the IP address of its host to create a man-in-the-middle attack. This may go entirely undetected as the intruder intercepts the data flow through the network. Wrong DNS server. The rogue server provides an incorrect DNS server addresses pointing the user to the nefarious website. Wrong IP address. The rogue server provides an invalid IP address, effectively creating a DOS attack on the DHCP client. Step 1. Threat actor connects rogue DHCP server. Step 2. Client broadcasts DHCP discovery messages. And step 3. Legitimate and rogue DHCP reply. Our step 4. Client accept rogue DHCP offer. Last, our step 5, rogue server acknowledges. ARP attacks. Step 1, our normal state with converged MAC tables. Our step 2, ARP spoofing attack. Step 3, ARP poisoning attack with a man-in-the-middle attack. Address spoofing attack. IP addresses and MAC addresses can be spoofed for a variety of reasons. IP address spoofing is when a threat actor hijacks a valid IP addresses of another device on the subnet or uses a random IP address. IP address spoofing is difficult to mitigate, especially when it is used inside a subnet in which the IP belongs. STP attack. conduct an STP manipulation attack, the attacking host broadcasts STP bridge protocol data units containing configuration and topology changes that will source spanning three calculations as shown in the figure. The BPDUs sent by the attacking host announce a lower bridge priority in an attempt to be elected as the root bridge. If successful, the attacking host becomes the root bridge, as shown in the figure, and can now capture a variety of frames that would otherwise not be accessible. This STP attacks is mitigated by implementing BPDU guard on all access ports. BDU guard is discussed in more detail later in the course. Last, our CDP reconnaissance. In the figure, a sample Wireshark capture displays the contents of a CDP packet. The attacker is able to identify the Cisco iOS software version used by the device. This allows the attacker to determine whether there were any security vulnerabilities specific to the particular version of iOS. So, let us check our understanding in our chapter 10. What a threat actor changes the MAC address of the threat actor's device to the MAC address of a default gateway? What type of attack is this? So, it is the DHCP starvation. A threat actor sends a BPDU message with priority 0. What type of attack is this? It is the villain hopping, address spoofing. A threat actor lists all the available IP addresses on a subnet. What type of attack is this? STP attack. A threat actor sends a message that causes all other devices to believe the MAC address of the threat actor's device is the default gateway. What type of attack is this? Villain hopping. A threat actor configures a host with the 802.1q protocol and forms the trunk with a connected switch. What type of attack is this? Let's see our answer. A threat actor discovers an iOS and IP addresses of the local switch. What type of attack is this? We have here our incorrect answers. Our 10.6 is our module practice and quiz. So, we have here our module quiz in LAN security concepts. Which layer to attack will result in legitimate users not getting valid IP addresses? It is our DHCP starvation. What mitigation plan is best for thwarting a DOS attack that is creating a MAC addresses table overflow? It is enable port security. For number 3, which 3 Cisco product focuses on endpoint security solutions? It is our web security appliance, email security appliance, and our NEC appliance. In 802.1x standard, the client attempting to access the network is referred to as the supplicant. It is true. Why the authentication with AAA preferred over a local database method? Because it provides a fallback authentication method if the administrator forgets the username or password. What is involved in an IP address spoofing attack? A legitimate network IP address is hijacked by a rogue node. In a server-based AAA implementation, which protocol will allow the router to successfully communicate with the AAA server? What 3 services are provided by the AAA framework? It is accounting, authorization, and authentication. What 2 protocols are supported on Cisco devices for AAA communications? It is Radius and TACHCS. Which service is enabled on a Cisco router by default that can reveal significant information about the router and potentially make it more vulnerable to attack? It's our CDP. What is the purpose of AAA accounting? It is to collect the report application usage. When security is a concern, which OSI layer is considered to be the weakest link in a network system? Layer 2. Which layer 2 attack will result in a switch of flooding incoming frames to all posts? It is the MAC address flooding. Because of implemented security controls, a user can only access a server with FTP, which the AAA component accomplishes this. Authorization. Last, which Cisco solution helps prevent MAC and IP addresses spoofing attacks? Is our IP source card. So, that's all for today's video, and see you on my next video, which is our chapter 11, the switch security configuration. Thank you for watching.